Good afternoon, everyone. I am Josh Matthew Oronce, and I will be presenting our paper entitled A Short Report on the Medicinal Plants from Mindanao, Philippines, based on secondary data published between 1970 and 2020. Please do take note, however, that what we will be presenting today is part of a bigger study on the various medicinal plants present within Mindanao, as well as their bioactivities and bioactive compounds. But I'd like to start by giving a brief introduction on natural products. So what exactly are natural products and what makes them special? According to Sharma and Sharma, 65% of the world's population depends on natural products as their primary form of healthcare. Natural products are known to be important given their ability to synthesize phytochemicals such as secondary metabolites. And these bioactive compounds confer pharmacological effects, which makes natural products a highly important resource in the fields of botany and medicine. Moreover, these natural products are known to be essential resources for both modern and traditional forms of medicine, given their capability to remediate illnesses. And natural products are of particular interest in our country due to their abundance. For instance, Mindanao is a hotspot for ethnobotanical studies, given that the island tends to exhibit high levels of biodiversity amongst flora. The topography of Mindanao, denoted by the darker shades of green, represents higher altitudes along with various types of mountain ranges, making Mindanao a conducive avenue for natural product development. Natural products have also been part of various ethnic tribes that practice ethnomedicine. And the continued practice of ethnomedicine shows how traditional healers demonstrate high levels of knowledge on natural products. Moreover, some of the known areas containing numerous medicinal plant species reported in Mindanao are the following: Zamboanga Peninsula, Davao Province, Surigao or Siargao, as well as many other provinces. And in line with the abundance of natural products in Mindanao, as well as their predominant role in medicine, this study seeks to create a narrative synthesis and generate a comprehensive compilation of identified medicinal plant species found in Mindanao among online journal sources published from the years 1970 and 2020. Specifically, the study intends to report prevalent plant families, plant species, bioactivities, and secondary metabolites. However, again, it is worth noting that this study that we are presenting is part of an even larger study with more objectives not included in this presentation today due to time constraints. For the significance of this study, it mainly revolves around highlighting the potential and favorable geographic location of Mindanao as a medicinal plant hotspot. Additionally, natural products can be used to synthesize cheap, potent, and naturally sourced drugs. The study's goal of providing more knowledge with regards to medicinal plants can also be used to validate the use of medicinal plants in traditional medicine in Mindanao. And most importantly, our narrative synthesis will be pioneering a comprehensive database that provides a thorough compilation of the collected and organized various isolated pieces of information which are found among selected studies. This therefore makes these types of information highly accessible to other researchers. So this study, the methodology of which was based on the published methodology of Economic and Social Research Council, and this study will primarily follow a narrative synthesis approach to summarize, interpret, and evaluate findings based on relevant studies. Upon looking in the flowchart presented, keywords such as ethnomedicine, medicinal plants in Mindanao, ethnomedicinal practices in Mindanao, and other keywords were utilized as search terms for various electronic databases, such as the ones indicated in the flowchart. And over 60 studies were identified. After reviewing the eligibility of the studies, 34 studies were excluded, while 26 studies were selected based on the selection criteria as shown on the left. Moreover, this will be expounded in the next slide. So here's a brief summary on the inclusion and exclusion criteria of the study as shown in the table. And I'd like to note that a full text review of each journal article was conducted to ensure that only relevant literature was selected based on the appropriate inclusion and exclusion criteria. Moreover, studies that performed extraction with or without in vivo or in vitro studies, in vivo or in vitro bioassays were included in this study. And these studies must involve bioactive medicinal plant species present within Mindanao and which were conducted within the time period of 1970 and 2020. Going back to the methodology, eventually the information with regards to these medicinal plant species were organized into spreadsheet tabs, namely publication, information, plant demographics, methodology, secondary metabolites, and plant bioactivity. After data collection, the collected data was then evaluated and interpreted for potential trends. So over here, we have a screenshot of a portion of the database which was mentioned earlier. And again, this comprehensive database was created in order to easily establish potential trends. Moving on to the results and discussion portion. The following data was generated after examining 563 medicinal plants from Mindanao and their corresponding bioactivities and bioactive compounds. It was determined that the family Fabaceae was the most predominantly cited family by studies, and this can be attributed to the numerous bioactive compounds possessed by plant species on the Fabaceae. Some examples of bioactivities include antioxidant, antimicrobial, anti-cancer, antipyretic, and anti-diabetic effects. Following this is Asteraceae. Its applications in medicine, as well as numerous bioactivities present in the species under it, are supported by previous studies that examine the bioactivities of the family and is considered to be one of the most commonly used groups of plants in traditional medicine. Some of their biological activities include antioxidant, antimicrobial, anti-inflammatory, wound healing, and diuretic effects. Aside from these plant families, predominant and notable plant families also include Lamiaceae, Fabaceae, and Piperaceae. The plant species with the highest number of reported bioactivities among the 563 different medicinal plants examined in the study were also identified. It was determined that Abelmoschus esculentus or okra, as well as Clitoria ternatea or balog have the highest number of bioactivities among the different medicinal plant families examined in the study. So for Abelmoschus esculentus or okra, which has been determined to have 8 different bioactivities, and these were identified using samples coming from the fruits and leaves of this plant. The numerous bioactivities exhibited by Abelmoschus esculentus is supported by previous studies which have characterized the various bioactive components of Abelmoschus esculentus. Okra polysaccharides in particular are considered to be one of the main bioactive compounds of Abelmoschus esculentus. Differences in the monosaccharide types of okra polysaccharides, however, do exist. In turn, these differences results in variations in biological activities. These okra polysaccharides, therefore, have high potential for therapeutic applications and novel drugs. Similarly, Clitoria ternatea has been determined to have 8 bioactivities, which were identified using samples coming from the leaves, roots, bark, and flower of this plant. And this finding is supported by previous studies which identified the numerous phytochemicals possessed by Clitoria ternatea or balog, and this includes anthocyanins. This is of importance since anthocyanins are considered to possess one of the most potent physiological effects among the different plant compounds, thereby resulting in significant bioactivities for Clitoria ternatea. Moving on, we have Luffa acutangula, which has been determined to have 7 bioactivities, which were identified using samples coming from the fruits and leaves of this plant. And this finding is supported by previous studies which have attributed the bioactivities of Luffa acutangula to the numerous bioactive phytochemicals possessed by this plant. Upon phytochemical analysis, it has been determined that samples coming from Luffa acutangula predominantly contains flavonoids, steroids, and tannins. In conclusion, 563 medicinal plant species coming from 90 different plant families were evaluated, and this came from 26 different publications. It was determined that antimicrobial effects as well as antioxidant effects were the most predominantly cited bioactivity. Under antimicrobial bioactivities, it was determined that Fabaceae, Lamiaceae, Fabaceae, Piperaceae, Malvaceae, and Apocynaceae were the plant families which predominantly contained antimicrobial effects. Moreover, it was determined that Moraceae, Zingiberaceae, Musaceae, Solanaceae, and Urticaceae were the plant families which predominantly contained antioxidant bioactivities. And again, after screening 563 medicinal plant families, it was determined that the top 5 plant species with the most number of bioactivities are Abelmoschus esculentus or okra, Clitoria ternatea or balog, Luffa acutangula or patola, Sutinia macrophylla or mahogany, Tinospora cordifolia or panyawan. And we recommend that future studies also consider the different environmental parameters such as weather characteristics, as this could potentially influence the secondary metabolites that the plant possesses, thereby also affecting its bioactive effects. And of course, we would like to thank the Department of Biology of De La Salle University, as well as Dr. Mariquit de los Reyes for her time and effort in helping us complete this study. Thank you for your time, and we are now open for your questions and your feedback.